Welcome to our channel. Today, we're diving into the fascinating world of gear manufacturing, a world of incredible precision and power. I mean, think about it. Gears are everywhere, from the tiniest watch to the largest piece of construction equipment. We'll explore 7 essential gear-generating processes that are crucial in various industries. Each of these processes has its own unique history, its own quirks, its own set of advantages and limitations. Stay tuned to learn about each process and how they contribute to building the machines we rely on every day.
First up is hobbing. And let me tell you, hobbing is the workhorse of the gear manufacturing world. It's a process for producing spur gears, helical gears, and worm gears, and it all happens on a hobbing machine. Now, a hobbing machine uses a specialized cutting tool called a hob. The hob is basically a cylinder with teeth that are designed to match the desired gear teeth. The gear blank, which is the piece of metal that will become the gear, is mounted on the machine. The hob rotates, and as it does, it gradually cuts into the gear blank. At the same time, the hobbing machine moves the hob along the gear blank, creating a continuous helical cut. It's mesmerizing to watch.
Next, we have milling, a process that's all about versatility. Milling machines are used for so many things, and cutting gears is definitely one of them. Unlike hobbing, which uses a specialized hob, milling relies on standard rotary cutters. These cutters come in a dizzying array of shapes and sizes, which is why milling is so great for producing a wide range of gear types and sizes. A skilled machinist can use a milling machine to create just about any gear profile you can imagine. Now, milling might not be as fast as hobbing, but it's got a few tricks up its sleeve. For one thing, it's perfect for smaller batches of gears, where setting up a hobbing machine might be overkill.
Okay, let's talk precision. When it comes to creating gears with incredibly smooth surfaces and tolerances tighter than well, you get the idea. Grinding is the name of the game. Grinding machines use a grinding wheel, which is basically a spinning disc coated with abrasive material, to remove tiny amounts of material from the gear teeth. It's like using superfine sandpaper, but with way more speed and accuracy. The beauty of grinding is that it can achieve surface finishes that are just unbelievable. We're talking about surfaces that are so smooth they're practically frictionless.
Chapter 4. Broaching, the internal gear specialist. Now what about internal gears? You know, the gears that have teeth on the inside of a ring or cylinder. That's where broaching comes in. Broaching is a process that uses a tool called a broach, which is basically a long multi-toothed cutting tool. The broach is pushed or pulled through a pre-machined hole in the gear blank, and as it moves, it removes material to create the internal teeth. It's a bit like pulling a saw through a piece of wood, but with way more precision. Broaching is incredibly accurate and efficient for creating internal gears, and it can also be used to create splines, keyways, and other internal features.
Chapter 5. Shaping the traditional craftsman. We can't talk about gear manufacturing without mentioning shaping. This is a more traditional method, and it's still used today for certain applications. Shaping uses a gear shaper, which is a machine with a reciprocating cutting tool. The cutting tool moves back and forth, gradually shaping the gear teeth. It's a slower process than hobbing or milling, but it's great for creating both internal and external gears. There's a certain artistry to gear shaping, and a skilled operator can achieve remarkable results with this method. Chapter 6. Laser cutting, precision at the speed of light. Okay, now let's jump into the 21st century with laser cutting. This is a relatively new process for gear manufacturing, but it's rapidly gaining popularity. Laser cutting uses a high-powered laser beam to cut through the gear blank, creating incredibly precise and intricate shapes. The laser beam essentially melts or vaporizes the metal, leaving behind a clean, smooth cut. It's incredibly fast and accurate, and it opens up a world of possibilities for complex gear designs. Plus, laser cutting is a non-contact process, which means there's no wear and tear on the cutting tool. Chapter 7. EDM, the spark of innovation. Finally, we come to EDM, or electrical discharge machining. This is another process that's perfect for creating gears with complex shapes and intricate details. EDM uses electrical discharges or sparks to erode material from the gear blank. Think of it like miniature lightning bolts carving away at the metal. It's a very precise process, and it can be used on a wide range of materials, including hardened steel. Now, EDM might not be the fastest process out there, but it's incredibly versatile and can create some truly amazing results. Thanks for watching. We hope you found this overview of gear generating processes informative. We just scratched the surface of each of these processes. There's so much more to learn, from these specific tooling and techniques to the incredible machines that make it all happen. Don't forget to like, comment, and subscribe for more in-depth videos on manufacturing and engineering. Let us know in the comments which process you found the most interesting, or if you have any questions about gear manufacturing. See you in the next video.